We are live. So, so today we have this new initiative, which is around GraphQL Learning Circles that you've taken. Uh, the idea is that we hang out to check out our Learn course. And today we're going to start with the Intro to GraphQL, uh, just like a getting started with GraphQL journey. And it'll be like a super basics course and like a beginner friendly way to look at GraphQL. So if you're very new to GraphQL or if you're just exploring GraphQL, this would be like a good place to hang out at. And also this initiative is going to go on for the next 2 weeks as well on our data and API show. This will be followed by the React one next week and potentially the Vue one the week after. Right. So for this week, we have GraphQL basics, and we also want to open this to the community as well. If people are interested in hosting a learning circle themselves, hang out on a live stream, we're happy to host you folks, and do reach out to us. So that's the learning circle initiative. um, and we'll see what it takes to look at what GraphQL is from like a fresh perspective. If you are working on front end or back end, doesn't matter. It's independent of the stack, independent of the language or framework of choice. So we look at the basics course and we'll go over the different concepts. I'll just post the link on chat. So I'm gonna go to comments. This is the learn course that we're gonna look at. I'm just gonna zoom in a bit more. Right. So the key topics and takeaways we're gonna look at today is like what is GraphQL, a little bit of introduction around that, and obviously the natural comparison with REST APIs and the different code concepts around it, which is like the documents, what is a query, what are the arguments, fields, nodes, and all of those fundamental core concepts, including schema and the type system, right? And introspection, which is also like a core concept, which enables a lot of front end tooling to be built. So we look at that, and we'll go over the basics of actual work that we typically do with GraphQL, which is like the queries, mutations, and subscriptions for building an application, right? The CARD API logic of your application. So that we'll go over, and finally we'll wrap up with the client server architecture. What are the different types of servers in GraphQL? Different approaches that different server implementations take. So we'll go over that. And finally, with the clients as well, right? There are different types of GraphQL clients, and in some cases, you probably don't need a client. It's just like a HTTP post request, so you can just use like your typical fetch API as well on your client to make requests. So we'll go over all of these with the next hour. And if you have questions, feel free to reach out on chat, and I'll be happy to take them over. Right. So yeah, let's start with the introduction around GraphQL itself. Like, what is GraphQL? And if you're very new to GraphQL, it's I'm sure you would have done some kind of API logic. You would have either written an API or consumed an API if you're a developer at some point. Um, if you're a front-end developer, you would have consumed APIs by writing some HTTP requests, and if you're a backend developer, you would have you've written API endpoints, right? So the GraphQL is basically like a specification, as a query language specification to write APIs in a different way and consume them also in a different way. But fundamentally, if you are familiar with your REST architecture, this is just a new syntax in the query language space. But everything else in terms of the transport protocol is HTTP in most server implementations. So you typically still make like a post request. You use JSON to make the request, receive the response in JSON as well, right? So that's fundamentally what you need to be aware of to get started with GraphQL, so that it doesn't feel daunting for you, and it's all like pretty straightforward to get started with. And if you look at this very quick example, very naive example, um, with GraphQL over HTTP, as I mentioned before, it's a post request. You have one endpoint, one URL for any GraphQL server. Content types, application JSONs as very simple JSON request body. And in the request body, you have a key value pair, which is query and followed by the GraphQL syntax, right? So that's the fancy syntax that we'll be learning with GraphQL. But it's actually pretty intuitive, and with all the tooling that the GraphQL type system and schema enables, this forming the query is not very difficult, and it's all pretty much easy with the introspection and all the tooling that's available. And the response basically is again JSON, and the interesting bit about the response is that it matches the format of the query. So if you're asking for details around the user ID and name, the response will match the same format in the key value pair that you get from the server, right? So very naive example, it's a HTTP post request. You call an API endpoint, which is like a single endpoint, whereas typically in your previous implementations, or you're consuming a REST API from a SaaS service, or you're writing your own REST API, you would use endpoints. Each for each use case, you would use your own endpoint, and you will write that from scratch, right? With GraphQL, the endpoint is the same, and then you will write queries and all of these differently. So that's the fundamental uh, introduction around GraphQL to put it out. Um, and we've discussed the client server flow, where the server which exposes like a simple GraphQL endpoint, client makes that request. So irrespective of what GraphQL query or a mutation or a subscription, whatever you actually want to make, it will be the same GraphQL endpoint that we make. So the URL will be the same, and the only thing which will be different is the query string, which is the syntax that we'll look at. So you'll send a JSON request body with that fancy string for the query key. That's the only difference between your normal REST API request and with the GraphQL request, right? But if it's obviously like a WebSocket or a subscriptions query, you will make use of a real-time use cases for WebSockets. So we'll look at that as well. But fundamentally, if you're making queries and mutations, which is like the CRUD API, create, read, update, delete, the typical use case, you will make use of a HTTP post with a simple JSON request body. And if you're worried about what happens to authentication or what are the other headers and whatnot, it remains the same. So if you've been sending authorization tokens to your REST API server, it will remain the same with GraphQL as well. So I just wanted to tell this upfront, so that it's easy for somebody who's coming in from an existing REST API architecture or flow, so that GraphQL is actually not something which is very difficult to consume. It's very easy if you understand that this is the concept behind what GraphQL is trying to do. It basically comes with a schema and a type system, which acts like a contract between client and server. The client basically can introspect the server and then identify what the GraphQL server looks like, right? So that's the base. Here we can look at an example GraphQL client setup. I mean, typically, with GraphQL, because of the schema and type system, you have the option of building a GraphQL client which can make use of special features, like you can do caching on your front end, you can do state updates, some magical state updates, because you know the types pretty much in advance, right? So there are clients which are built specifically for GraphQL. This is not a working example. I think this is just a simple way to put out like an SDK that can be consumed on the client. But typically, if you're building a very simple app, you can still get away with writing fetch APIs, which is just a HTTP post request, right? So you don't need a client. There's no there's nothing on the spec that makes you work with a client as such. It's just HTTP request at the end of the day. Clients actually do add some value in certain use cases, so we look at that in the graphical client section as well. But typically, for a very simple app, I would still recommend just exploring it with the simple plain old HTTP post request, and then once your app becomes complex, you can carve out the portions separately, and then make use of the client so that the state management becomes easier globally. Right. So let's look at the GraphQL versus REST comparison, which typically happens when you talk about GraphQL, right? So um, the interesting bit with this comparison is that they're not GraphQL is not meant to replace REST as such in a practical scenario. They can coexist together pretty well, and the reason why I say that is because a lot of times when you're writing GraphQL servers from scratch, the underlying logic uh, on the server would be to contact a REST API and then get some data, because there's a lot of REST APIs which are live right now, and which needs to be communicated with to get some data. It could be an external SaaS service, or it could be your database, which probably already has a REST endpoint being written by somebody else. So the GraphQL as such is still complementing. So they are just complementing each other, GraphQL and REST. There's a lot of REST tooling that exists pretty much, and for logging and monitoring and whatnot, which is just still kind of pretty much relied on by large companies. So REST is here to stay, and it's going to complement well with what GraphQL is going to offer in terms of the tooling that it brings. Right. So in terms of comparison, I wouldn't say it's GraphQL versus REST. I would say GraphQL and REST. That's typically how I've approached these two technologies. Right. So these two protocols or query languages and whatnot, whatever you call them. Right. So this is again a naive example of a HTTP REST API call. You can make a simple GET request to an API endpoint call, let's say API user, with query parameters in your URL, which is ID equal to 1. And you get a response, which is a JSON. You get the ID and the name. And you can get and for a different data request, like an address of the user, you make another API call, which is API/address, pass in the user ID as the argument, and get the street and city as the response, right? So if you notice here, you're making two HTTP GET requests, and you're getting corresponding responses for each of these HTTP calls, right? So that's the typical REST API structure that we've all been using for a pretty long time. Now come with GraphQL, the change here is there's only one endpoint, which is a post request. Again, HTTP request, but it's a post request now. There are some server implementations which do support GET requests as well, but there are limitations around what you can do with the GET request in terms of the URL length and the arguments that you pass in and whatnot. So typically it's good that if you work with the post request. And if you look at this query, this is the GraphQL syntax that I was talking about earlier, and this is basically asking for users ID, name, and the address and the city details of the address, right? So if you look at the request and the response, it looks the same format, the same JSON structure that you see on the left, and the response is on the right. The difference here is that every time a new field or a new node gets added in the query, the response changes correspondingly, right? With the REST APIs, for the same use case, we did two API calls. So if you go up, we can see that we did API/user to get the user details. We did API/address to get the address details of the user. Now the change here is GraphQL server lets you query for whatever detail of the user that you want in a single query, which makes the number of round trips lower, and the response all comes in one shot, right? So on the client, it becomes a lot easier to consume this response, map the user to the address with the same nested object, and then process that on the client, right? This is assuming that this nesting of query is enabled or is written. The logic for that is written on the GraphQL server. Again, there's nothing magically that's happening on the GraphQL server. Somebody has to write that piece of logic, but GraphQL enables that logic to be written a little more easily, a little more structure around that, because there's types involved and there's a schema for which you can specify what's the nesting layer and whatnot. So that makes it easy, and that makes it more structured to make this possible, to make the whole querying of all the fields and nodes easily. Cool. So this is the query request response for different examples. When I ask for the ID of the user, I just get back the ID. When I ask for the ID and the name, I get back both the fields. So the client is empowered now to ask for the JSON keys that they want in the response, uh, assuming that these are the fields that exist in the schema. But if you look at the REST API in this example, I asked for the user's ID, one, which is the argument, but I'm getting ID and name irrespective of this endpoint, right? So the ID can become two, but then I'll get the name of the ID two as well. The reason being that the server sends these two keys as the response by default for this GET request. With GraphQL, you have the option to not request for fields that you don't need on the client. So that's the benefit, that's the flexibility that GraphQL gives you, which means that you can now focus on writing modular components which are relied on a particular data set from the backend. So if a, let's say a profile page is reliant on ID, name, and the profile pic, those are the only fields that you need to fetch and display on the client. So GraphQL query lets you query only for those three fields, ignore the rest of the fields, which means you save on the response size, you save on the number of round trips that would have typically happened with a REST API architecture. Nothing is preventing a REST API to be written in a way that you can ask for. You can write as many endpoints which are as modular as possible, which will give you exactly what you want. But it's just more boilerplate work on the REST API side to replicate what GraphQL gives you. And of course, there's a schema and type system which can be replicated with the type safe language on the REST API side as well. But it's again, it's not part of the spec, and hence it's not mandatory for anybody to implement it. So it's all driven by the user and the community to write a type safe API with REST APIs. Uh, and with GraphQL, it's type safe by default to begin with, and hence it becomes a lot easier to structure the APIs in that way. That's the fundamental difference I see with GraphQL and REST APIs. And we've seen all of these benefits, like avoid overfetching. So you will specify exactly what fields you want, prevent multiple round trips. So you prevent multiple API calls to be made. Let communication overhead with API developers. This is because now once you know what you want to fetch from the server, you don't need to ask the backend developer to change the API endpoint to say, I just need these two fields, or maybe I need one more field. So rewrite the API and whatnot. So this communication back and forth can be avoided with GraphQL. And GraphQL is self-documenting. I have repeated this, the schema and type system lets you figure out that this is what the backend looks like, and because of that, you will be able to now fetch the schema on the client and then introspect that whole schema and then figure out what is actually the backend looking like. And this can be compared to your Swagger spec in REST APIs, where you will have the documentation of your API pretty much. So on the the verbs, REST API verbs that we typically use. We use get request for fetching, post for inserting, updating will happen through put, patch, or delete, and watching or subscribing to data is typically the buckets. Right. So that's the verb terminologies that we use for different CRUD API requirements. With GraphQL, most of them becomes post requests. Some servers do get for some use cases, but let's assume that it's post requests for all queries, all requests basically. And for fetch, you use query in GraphQL. For inserting, you use mutation, and for updating, you use mutation again. And for subscriptions or writing real time data, it's subscription on GraphQL. Right. So that's the difference between the different verbs that you use and for different use cases between REST and GraphQL. Um, and schema and system, we've already looked at it, and this is what I think will probably frustrate a few users in the initial journey, which is the status codes that are being returned in both REST and GraphQL. Right. With REST API, if you've been using it or consuming it in some form, the standard is that if you get a 200 or 201, whatever, you are guaranteed of a successful response. If something is 4xx, either it's 400 or 401, there's something wrong with the request, which is either bad request or unauthorized request, if it's 401 and whatnot, right? And if it's 500, 502, whatever, that there's a gateway error, there's a timeout error that happens in those status codes. So REST has a standard which has already defined that these status codes are meant for this kind of an error message, and the server or the client needs to figure out what needs to be done to fix this. Either the request is bad, so change the query, or if you're unauthorized, add the token that's needed. So that was very clear on the REST API side on this status code being handled. With GraphQL, any response, any valid response has to be a 200. Now the response can be a successful response or an error message or an error code, whatever, right? So it could be an unauthorized query, it could be a bad request, whatever, but the response has to be 200 status code. Now that sounds a little weird, but that's how GraphQL is handled, because the GraphQL spec says that your error message has to be part of your response body. So your response body has a data key in JSON, and there's also an error key, errors key in GraphQL responses, which your client should actually look at. So your client should look at data and errors. So if there is an errors object, then you have to assume that the query is not completely successful. And there's also another weird case where you could get both data as well as errors in the same response, in which case there is partially successful data that you've gotten from GraphQL. But if there's an errors, then you have to account for that in your front-end client, either by showing a different UI or showing the error message to the user to say that something has gone wrong. So that's the little throw off for people who are getting started with GraphQL. The whole handling of error codes, error messages, and the way responses are handled in GraphQL. That will be still a big issue for anybody who's new to GraphQL. This will also be slightly weird for backend developers in use cases like, let's say, you want to do logging and monitoring, you want to monitor APIs. Typically, with REST APIs, you can monitor for 401s for unauthorized, maybe some 400 for bad requests. But now that's not going to happen anymore, because you have to process the JSON response to figure out that if there is an errors object in the response, and then parse the whole key value pair to identify what kind of error was this GraphQL request giving. So that's going to make a lot of existing REST API tooling obsolete with GraphQL's adoption. But again, There's tooling being built for GraphQL specific use case on how to process the error requests and how to do monitoring logging for GraphQL itself. All right, so that's something we look at with the upcoming sections as well. And caching. The caching, I talked about this a little briefly for the client side. On the server side, the problem typically occurs because you are using only one endpoint in GraphQL, which means you cannot cache that one single endpoint, because caching one endpoint means all the requests to that endpoint will now return the same data. With GraphQL, the endpoint remains the same, but the query, the request response is different every time you make a request, right? So the request is actually in the request body. The actual query that you want to make is in the request body. With the REST APIs, you can typically do get request to, let's say, user/1, and you'll get the data for the user ID1. That's the typical standard that we follow. But with GraphQL, now you have to specify this query inside the request body of a post request, and hence caching becomes a lot harder to think about. You cannot use the CDN tooling for GET requests, caching, and whatnot. So all of this becomes slightly different to handle. Different clients, different server implementations do it differently. Client side caching is obviously different. On the client, you can, because the clients know the schema, it can store the data, and if there is a change in the data in the say for the same types, it can update the state automatically, and hence all the components who are subscribed to that will be updated automatically. So that's the magic that the clients bring in. The server side caching becomes a lot harder when you compare to what you've been doing with REST APIs in the past. Cool. So I look at the core concepts pretty quickly. GraphQL document is a fundamental uh, request string that you see, which is this syntax which opens these brackets and you enter some fields and nodes in the syntax format. Right. So there's operation in GraphQL, which could be query, mutation, or subscription, which we've talked about before. And if you've not given any operation, it's a query by default, but you can explicitly mention that it's a query and then ask for the different fields that you want. And if you look at this particular example, so again, this is the operation name. So query is the operation name. The author is the node that you're trying to query. Limit :5 is the argument. So whatever that comes inside the brackets, this open brackets, this is the argument for a GraphQL query. And we have some more fields within the node author. So you have fields here. We have arguments, which is within the brackets. We can also parameterize some values by using variables. So for example, this limit has a constant called phi, but typically your front-end client can pass this value dynamically, which means you can now use like a variable which you can pass in the request body later. So you can have a dollar limit, pass in the type of the variable. So in this case, it's an integer, so you pass it as int. GraphQL has a few defined types, like the int, bool, and so on, right? So we have primitives here, and we have a schema a type which can be extended with custom stuff as well. So this is limit. This is the variable that we are using here. This could be named whatever. You can pass in the string or named or whatever type of the variable is, and then you can make use of that in the argument itself. And you will pass in this JSON for the variable. So this will be in the variables key in the request body, and you will pass in this limit 5 or whatever the value that is. An operation name is the name of this particular query. For example, you're making a query for author. uh, and you want to identify that with a particular query name or an operation name. This would be the operation name. So the fetch author is the operation name here. This is useful because with GraphQL, you can actually make multiple queries, multiple operations in the same request. On the same post request, you can make multiple uh, GraphQL queries, which means I can fetch author with ID 1. I can also fetch a set of authors as another query. And the response will be a single response from the server, but then these will be two different JSON keys that I can handle. In that case, you're fetching the author node in both the cases, but now you want to specify that this is the operation name for this one, and fetch authors, the plural form, is a different operation name for this particular query. So this is all customizable. You can give the name for better identification on the response side of things. Cool. You can also make aliases. You can do uh, if you are having a same field name with different arguments that you want to pass in, you can give an aliases. And then a very simple use case is if there's a profile pic that you want different thumbnail versions of it, you can pass in arguments, say size large, small, and then you can get a different alias name in the beginning. Right. So that's possible. There's also a concept called fragments, which you'll end up using if you are building a production ready app, because you'll be reusing lots of fields in a query. So if you're using like a query, fetch author ID 1, and if you're reusing these fields from the author node, which is the ID name, the timestamp, some fields, right? And if it's being repeated in multiple queries, you can actually define them in one place and then just use it in multiple places by just using the syntax of triple dot followed by the name of the fragment that you've defined, right? So this is pretty useful if you're building a pretty complex app where the fields are being repeated multiple times and you don't want to type them in or reuse or create them from scratch every time you're making use of this query. So this is basically like a functional, like modular way of thinking. Define it in one place, reuse the fragment in other places where you need the same set of fields that you want to query for. Cool. Directives. This follows the at directive where you can specify that, hey, include this field name only if it falls under a particular condition. Skip this field if it's following a certain condition, and deprecate it if this field is deprecated and whatnot. So you can have these directives additionally as well. Cool. With Hasura, we support a directive called @cached, which is used for server-side caching, and that will be a cool feature to try out as well. Right. So the next bit is graphical introspection. We've talked about the schema and type system multiple times, but that is actually the backbone of what all the modern tooling that you get with GraphQL, because what GraphQL server exposes is the schema of the backend that has been defined, and any client which has access to the server with the right authorization as well will get access to the backend schema. And by making a simple GraphQL query to the same server, the server will return back a JSON response and data key, and that would contain the entire schema that the client can again then process and send back to get responses, right? So you can automatically construct GraphQL queries by just reading the introspection a response that you get from the server. So you have the query operation type. You can see that the server exposes these queries, which is a schema, type, and type name, right? All of the community tooling that's being used like GraphQL or Playground, all of them leverage this introspection feature to provide self documentation to the user. So I'm going to give you a quick demo of the GraphQL interface itself to show you how that actually works and why is this pretty useful for the end user as well, right? So once you look at the demo, it'll be pretty useful to know the power of GraphQL and why it's loved by the front end developers and then the whole community pretty much, right? So meanwhile, this is loading. So we'll quickly create a couple of types in GraphQL. So with the Hasura, you can create a table and then it'll give you a GraphQL schema automatically created. And with that, we'll get to use the GraphQL interface pretty quickly, and hence you'll get to know what the power of GraphQL itself pretty quickly. Cool. So meanwhile, I'll go to queries. So the next set of concepts would be around queries, mutations, and subscriptions. This is your typical day-to-day interaction with GraphQL as a query language. If you're building a front-end app, you'll make use of queries, mutations, and subscriptions. And we'll go all of this in the demo that we look at here. So there's a latency from where I am to the server's location. So it's going to take a little bit more time. But if you look at the query, mutation, or subscription, and the syntax is the only bit that you need to learn. But actually, it's a lot easier once you get the hang of GraphQL interface itself, where it becomes a lot easier to just autocomplete queries, and it'll be intuitive as you type along. It gives you suggestions on what's happening in the backend server, what is being exposed by the schema for your particular authorization token, what is being exposed and whatnot, right? So that's always there with GraphQL. So this is the slightly modified version of GraphQL, but fundamentally this is the idea behind this interface. You have an endpoint, you're passing in some request headers, and you will also pass in some query that we look at, right? So let's go to data. We should probably create a table. So I'm going to click on create database. So once the database is created, I'll be able to create some tables. So Hasura basically gives you GraphQL APIs on top of databases, so you don't need to write the server. So all the server handholding is done by Hasura. You can focus on connecting to Hasura and then querying it as well. So that's the bit I'll look at today. So I'm going to create this author table, ID, which is of getting integer, and let me create a few more fields with text. Let's create a timestamp, create a profile pic, which is again a text, make it nullable, and I'm going to add this table. So we'll now have a table with 4 fields. We'll look at that in the API layer. So this is what I was mentioning. So this is a graphical interface where you can autocomplete the queries. There's an author schema that's been defined by Hasura as you created the table at the backend. So this will also have the autocomplete feature where if I start typing in, it will show the list of fields that are possible. You have ID. As you type in name, it comes to the name, and there's profile pic, and there is a created timestamp. Right. So I'll rename this to, let's say, fetch authors. If you look at this query is the operation type, which is actually the query, mutation, or subscription. This is the operation name, which is the fetch authors, the name that we identify this query with. This is the node, and these are the different fields that are part of this node. And if you feel fancy, you can also give in an argument, which is limit phi. This is the arguments that we talked about in the previous core concepts. Now, if you want to send in this limit as a dynamic value, we can use a variable, which we need to define in the operation name argument. So we'll say limit as an integer, and here we are passing in this limit variable name over here. And the way to request this would be to pass in the query variables. So I can pass in the limit as a variable or some value, and this could be dynamically formed on your front-end client. Right. So if I go to the network tab and actually show you the request that's happening, you can get a better sense of the GraphQL requests. So the operation name, we can ignore the response. We can look at the operation name, which is the fetch authors, the query, which is the GraphQL query that we just created, and the variables. So these are the three keys that are available here, and this just basically is a JSON object. And if you look at the response, it's an errors key, so there's an error because of connection to Postgres not applicable. But typically, you will get data key with the response of the author and so on. So that's the thing with the typical queries that you make. Now going back to um, the nested query. So I can actually try it out in GraphQL. This particular one, we'll log in. So, this is like a pre-built interface, pre-made interface, which is pointing to this particular GraphQL endpoint, and this is a modified version of GraphQL. All right, so here I'm going to just copy this query and paste it over here. Right, so this is going to give me a set of to-dos that I have created under the user ID that I used under this token. So this is important because I have a field. I have the name is a node of this user's. So users is a node. Name is the field under the node, and you have another set of nodes and fields. If you have to dos, which is under users. So what this means is you can now do a nested query. So if I do a limit one, it'll probably be a faster query. Yeah, so I can do limit phi, and you can see that there are some users. Probably for one user, the to dos are empty. For another user, there are a couple of to dos, and so on. Right. So we have uh, different data for different users, but the format of the data is exactly how we've requested in the first place, which is the name and to dos keys. And to dos is a nested object with title in between, so you have a title in the response. Cool. So this is GraphQL queries. We've seen the variables, usage, and whatnot. Let's look at mutations. This is pretty similar, so I can just copy this mutation. And I'm just going to play. Here, what we've done is we have inserted a new to-do with the ID, this one. This ID was automatically generated. The idea here is that I've inserted a new to-do with this title called new to-do. And I've gotten back the ID value as the response, right? So end of the day, it's a mutation. So you're inserting or updating, deleting something from the DB. So you're not just the DB, it could be the server processing it for doing whatever task that it wants to do. In this particular case with Hasra, it's basically directly talking to the DB, um, and there's a insert that has happened. Cool. Again, you can use the variables by defining a variable name for this sending in this objects, which is probably dynamic on your front end, and then you can make use of that over here. Finally, subscriptions. This would be a pretty interesting use case. I can just quickly copy paste this. And here we can get the list of online users who are here, right? So we have a list of users who have logged in recently. So we can see the last seen dates. There's the ID, there's the last seen user and name columns that appear over here. This subscription makes this consuming this subscription data makes this a lot easier for the front end client to look at, right? So this is these are the three fundamental concepts around GraphQL where you'll be working with on a regular basis. Is writing queries, mutations, and subscriptions, depending on what kind of app you're building. Right? So now let's look at um, server implementations. Um, we've looked at the power of GraphQL on the client side. It's all pretty pretty beneficial for the front end developer because they get this self-documenting API. Documentation is pretty much available. The autocomplete, all the tooling is available to try out the API. A lot better than what Swagger used to give you with REST APIs. This is all pretty good for the front end developer, but for the backend developer, what it takes to build an API and whatnot. So that's something that you have to look at. So there are different ways to write or think about how a GraphQL server can be built. Right. So the first one is the resolver approach. This is the basic way of writing GraphQL servers by default. So you irrespective of languages or frameworks, you choose this resolver approach where you define the schema yourself by hand, and for each schema and a type system for a query mutation subscription that you define, you write a resolver function which will be the logic, which will contain the logic for the query or a mutation that you have written, that you have defined, and the logic can do any sorts of processing. It can make HTTP calls, it can connect to the DB, it can do whatever it wants inside the function. Think of a resolver function as your API endpoints. So let's say in your REST API, you have a post request, you define the endpoint for the post request, and you define some logic handler for that, right? So in GraphQL, it's very similar. You define a resolver function to handle that. The problem with this kind of a resolver approach is the n+1 performance problem, right? To make it simpler to understand, let's consider the example of fetching authors and articles. So here we had authors. So we looked at, I think we have users, for example, and we have to-dos in this case. So we had users and we have to-dos. Now for each user, you've written a resolver function to fetch the name of the user. And for each user, you also would have written a resolver to fetch the to-dos of the user. This this is basically two requests for one user, right? Now the problem becomes bigger if the number of users that you want to fetch is higher. So if you want to fetch 5 users, you're basically making that many plus or nested queries. So the n+1 problem is very prominent here because the number of function calls are pretty big, and because of that traversal, your performance will be generally lower as you scale along and as you make requests which are pretty production ready for your application. So that becomes the n+1 problem. So that's something that different implementations try to solve by different means, right? So let's look at one of the means to solve that, which is batching of your queries. So there's a concept called data loader. It waits for all the resolvers to load in their individual values and basically batches all of them and maps it with the requested keys that you have. So, for example, here it will make one batched query for all the users' name. It will make one batched query for all the to-dos of all the users, and it'll try to collate all the values and then map it to the respective user during the processing of the response. So before sending it back to the client, you will do some sort of processing by batching the data. This will avoid the n plus one requests problem, but you're still making multiple requests. For each nested layer, you're making one more batched request. And there's also processing involved in mapping out the data that can be processed and sent back to the client in the same format that the client is expecting, right? So there's still work involved, but it's solving it's reducing the number of requests being sent on the data loader side. The other approach is the compiler approach, which servers like Hasura, PostGraphQL, and the likes take, which is to say that I receive a GraphQL query, um, and and if it's just connected to a database, I'm just going to compile this GraphQL query to a SQL query, to a database query, and then execute in a transaction. And it'll be very highly performant because instead of making multiple SQL statements individually, you're making one single SQL statement, which is compiled for performance, and you get back the response pretty quickly, right? So that's the compiler approach. And Hasura does that when it's connected to a database. Then there's the hybrid approach where if you're connected to a database, you make use of the compiler approach. If you're making use of an external REST API for a SaaS service, you can make use of the hybrid approach where compiler is for the database connectivity, batching of data loader queries is for the other REST API queries and whatnot, right? So you have a hybrid approach typically used by a lot of these servers, including Hasura, uses hybrid approach of doing compile SQL for the database connectivity, but also falls back to the batching of data loader for your typical other queries where you're just combining data from different sources, right? So that's the hybrid approach that's typically recommended on the server side. Finally, on the clients, as I mentioned at the beginning of the show, it's just a HTTP post request. So you can actually make a fetch API call, which is to a single GraphQL endpoint with the method post. You pass in some headers. You pass in a request body, which contains a query key, which contains the variables, and optionally it contains the operation name as well for the request body. And then you get back the response, which contains data key and the errors key if there is an error in the response. Now, if you look at why do you need a special GraphQL client, you can get away with just writing fetch API calls. There's a little bit of magic that's given by GraphQL clients in terms of consuming real-time queries through subscriptions, which is a lot easier. Managing the state, some clients let you automatically update your state, which is synchronized with multiple components. So same component is being reused in a different part of the UI. All of them gets updated. The data changes reflect across the UI. So updating cache will reflect the change on all of these UI components, right? So that's the benefit of using a specialized GraphQL client. It will reduce the boilerplate that's required for a real-time app with WebSockets to be set up. And finally, there are different types of clients. So we have Apollo and Relay implementations for the front end. There's also Urkel. There's also a different types of client called a Fluent GraphQL client, which lets you like write your GraphQL query like normal syntax, like the SDK type syntax that you typically use in the chain functions. And then that's where Fluent GraphQL clients are pretty useful. It will reduce the boilerplate that you want to write, and in some cases, the queries can be written in completely different syntax than what GraphQL spec lets you, because underneath the client converts these special syntax into GraphQL syntax, so that you don't need to worry about building that on your own. Right. So Fluent GraphQL clients are different set of clients, and you can check them out in this awesome list that we have on GitHub. There's a few examples for GraphQL with React, and all of these different Fluent client libraries. Cool. So this is fundamentally what we wanted to look at today, which is right on time. So what next? So now we've learned the core concepts of GraphQL. We've learned about introspection. We've learned about the schema and type system. We looked at queries, mutations, subscriptions on the console using the GraphQL tool. So we've learned all the fundamental basics around GraphQL. We've looked at the differences with the REST API as well on all of these different sections. As a next step, I would recommend you to take the backend course, which is the Introduction to Hasura backend course, and that would be like a good introduction to understand a little more deeper into what are the different ways you can create queries, mutation, subscription, how do you consume them, how to think about authentication, authorization with GraphQL, how to write your own GraphQL server from scratch. So all of that is part of this introduction course with Hasura. So you can try out all of this. How do you create nested data and request response formats and whatnot? How to write custom resolvers with your own Apollo server and whatnot, right? So all of this is covered in this course. This is the natural path in your GraphQL journey. Once you're done with the introduction series of GraphQL, you can take the backend series to get things going on the full stack experience, right? So with the backend course, you don't need to write code, only in very specific cases like the custom resolver bit. If required, you need to write code. Most of that is just most of the other things is boilerplate set up on the UI with the Hasura console, and you'll get a backend that you can play around with and create a production ready app pretty quickly. So I would recommend you to try out this as well. And as part of the GraphQL Learning Circles for next week, we have the React one. So we'll go with the React Learn course. So if you're new to our Learn courses, we have a bunch of front-end tutorials as well. So we have GraphQL with React, Vue, TypeScript, and all of these popular frameworks. Next week, we'll look at GraphQL with React, which has been recently updated with React 18 and all of the new changes coming in from Apollo client as well. So we look at building like a real-time to-do app, which is all of the fundamental concepts around the clients and including caching and so on. So that'll be exciting to look at as well. That's mostly it for this time. So I'm just looking at the chat for questions. There's a user who says, "Hi, Valerie. Hi, Valerie. Thanks for joining in. I know it's kind of late, but I think catch up on the recording to look at the core concepts as well." Awesome. So that's it for today. Stay tuned for the next week's Learning Circle episode. And if you want to host your own version with any of the other GraphQL concepts or tooling, feel free to reach out to us. We'll help you set up an episode for you, and you can go over a tutorial just on the stream live, read out once, try it out, and then learn with the community and contribute to that as well. So yeah, and thanks for joining in, folks. Until next time, see you around. Bye bye.